All right, the last thing we're going to look at in the first half of this module is the analog write command. So the Arduino itself does not have a true analog signal generator. Instead, it uses what's called pulse width modulation to create a pseudo-analog signal. The way this works is it actually turns the digital output port on and off very quickly. And the duration that it's on versus the duration that it's off sets up a variable voltage, or really a perceived variable voltage, that can be between 0 and 5 volts, or whatever the reference voltage that you set it to is. The input to this command is an integer between 0 and 255, which is an 8-bit value basically. And a good example of what this looks like is shown here. So in a 50% duty cycle, when you set it to something that's half of 255, right? So a 128 or something like that, right? It's on half the time and off half the time. And so the average of this is going to be half of the maximum value. In a 75% duty cycle, it's on 75% of the time and off 25% of the time. So again, the average of this is going to be 75% of the maximum value. In a 25% duty cycle, it's on 25% of the time and off 75% of the time. So we can use this to control the strength of a motor, or the brightness of an LED, or a lot of other different things. And we can even use different circuits to smooth out or to average that signal over time to create a truer continuous analog signal if we need that. For a lot of things, again, like motors and LEDs, they don't mind too much being turned on and off, on and off, on and off very quickly. So it doesn't matter that we're having a pseudo analog signal rather than a true analog signal. And the perception of something that's on half the time and off half the time is pretty much the same thing as something that's on at half brightness all of the time. So it doesn't matter that much for us that this is not a true analog signal. So let's take a look at, we don't need to make a whole lot of physical changes to our circuit this time, but we are going to need to make changes to our code. So I have the same circuit that I built out here last time, where I have the potentiometer, the button, and the LED. And rather than changing the circuit physically, I'm just going to change how it behaves by changing the code inside the system. So the first thing I want to do is actually I want to turn the LED on at a brightness that's a function of the pulse width modulation using the potentiometer pin. So I'm going to ignore the button portion of this for now and basically treat it like it's not there. I'm not going to delete it because I'm still going to save it for if I want to use it later, but I'm just going to let it sit there. And then what I'm going to do here is I'm going to try and add the analog write command to write the brightness of the LED as a function of the position of the potentiometer. So let's use analog write. And I'm going to use pot position divided by 4. Now the reason I'm dividing by 4 is pot position is a 10-bit integer. So it actually goes from 0 to 1023. The input to the analog only goes to 0 to 255. And they actually show you this in the reference for the Arduino kit, where if you're using an analog read to get a value, they divide that value by 4 to actually set the value of the analog write. Also, it looks like I forgot to include the pin that I'm going to write to inside this, right? And there's a little comment here, which actually, if I wanted to, I can copy and paste into my code. And let's set this to our LED pin. So we'll set our LED pin using the analog write to the position based off the position of the potentiometer. Let's write this out and see what it looks like. Oh, don't forget to plug it in. So now when I change the position of my potentiometer, see it gets brighter or dimmer. Again, you can't really see that it's flashing because it does this at a rate that's fast enough that you can't see it. And if I get too low, it really just turns off, right? So now I basically created a dimmer switch for my LED. So that's basically all the functions you need to be able to do to be able to control basic mechanical systems or electromechanical systems. We have analog input, analog output, our digital write, our digital read. We have analog input and analog output, or analog read and analog write. We've discussed some of the limitations and the functions that we're using in terms of the rates and the methods that are being used to actually accomplish those tasks. The last thing I want to talk about, and since this video has not been too long yet, I'm just going to incorporate this into this one, is changing the behavior of how this thing works based off of the code to get some desired output. And say what I really want to do in this example is I want to press the button, and then based off the position of the potentiometer when I press the button, I want it to have a certain brightness, and then I want that brightness to decay until it gets down to 0, and then I want it to reset. So to do that, the first thing I want to do is I'm going to set the brightness of the LED when I press the button based off the position of the potentiometer, is I want to know the position of the potentiometer before I do anything else. So what I'm going to do is I'm going to move this loop here up above, higher in this system. And then what I'm going to do is I'm going to have a condition here. I'm going to reset a value, right, of my position of the potentiometer to a separate value that I can decay, right, inside this if statement. So I'm just going to say integer. I'm going to call this current val equal to pot position. So when I press the button, rather than turning the LED on, I'm just going to set the current value integer equal to whatever the pot position was in that same loop, which is going to go pretty quickly, right? And then what I'm going to do, so I'm going to make a while loop. And so a while is a conditional loop. And again, for most of these things here, as we get to the more complicated functions, I really encourage you guys to use the reference to make sure you're using the appropriate syntax for this. And if you know which function you want, you can just search for it. And if you don't know which function you want, you can just go through and look for it. So you have while and then a conditional, right? And then you're going to do something else. And then in this case, they're incrementing the var as getting larger and larger. I'm going to decrement my values. And if I want to look for functions inside that, I can look for those different kinds of things inside here. I'm just trying to go back to the base. So there's the addition, there's the increment, there's the decrement value, the minus minus. So what I'm going to do in my while, I'm going to say while my current value is greater than 1, I'm going to decrement the current value, right? So I'm going to say current value minus minus, which means whatever the current value is minus 1. I'm going to set my brightness. I'm going to take this one out because I don't want to use it, but I just want to have it there. But I'm not going to use my pot position, I'm going to use my current value. And then I want to wait a little bit because I don't want to go through this too quickly, because if it goes through it too quickly, I won't be able to see the delay. Let's do a 10 millisecond delay. And if I wanted to, I could also do current values pot position divided by 4, and then I could not have to do the divided by 4 here, but it depends on how you want this to behave, right? So let's read through this and see if it's going to work the way we want it to work. So first thing I do is I get the position of the potentiometer. I'm printing that out to the serial command, which I can use to debug just to make sure things are working properly. I'm getting the value of the button. If the button is evaluated to true, then I'm going to set the current value equal to the pot position, right? If the current value is greater than 1, which for most positions of the pot position it will be, I'm going to go through this loop where I make the current value 1 less than it previously was, write the position, write the current value divided by 4, which is just the transformation to the 0 to 125, to my LED pin, wait 10 milliseconds, and then go through the loop again until that value gets to where this is not true. Again, once the current value goes to 0, then it'll stop. And if I wanted to, I could also print out my current value. Actually, that's not going to work because it will go inside. It has to be inside this loop. But we can put it in there if we want, though. So if we want to see the value go down as it goes down, we could do that too. All right, let's try uploading this and see if it works. So my current value was not defined inside this because it's defined inside this if statement. So when I first ran this code, since the if statement hadn't run, the current value was never defined. So let's define this as a global variable as opposed to a local variable. And we'll set it initially to 0. And then down here, I don't need to initialize it again, so I'm just going to say this current value equal to pot position. And again, this thing, the debugger here should help you figure out what happened with this. So I knew that this is where the error was. It's saying current value was not declared inside this scope, which means that current value has no definition, which meant that it didn't know what current value was. And again, I had defined current value inside the if statement. So because that if statement was not true, the very first time I tried to go through this loop, current value never got defined, which is why I knew I needed to move that so current value is defined even if this if statement never evaluates to true. All right, so we've uploaded. I can push the button. Turned on. It's decaying slowly. Turned off. I don't know what position I'm in my potentiometer here, so let's turn our serial monitor on so we can watch this a little bit more detail. So I'm going to set this to a small value. Set it to, yeah, 90 is good. Starts off bright and goes down. Again, that 97, that's the value of the potentiometer. If I bring it up to a large value and then hit it, you see it's decaying. It takes kind of a while for it to decay, so maybe that delay there is too long. If we want it to decay faster, I can make it decay twice as fast by removing the delay down to 5. The serial print also does take some time, so even if I made this delay 0, it would still take some time for it to decay. So just as an example here, if I just comment that out so it's got no delay at all, it will still take a little bit of time because it has to refresh this display with the way I have this set up. So that's as fast as it can write that out. So another thing that's an important point when working on these, it does take time for the microcontroller to execute the steps that you're running. So if you're trying to do something very, very quickly, then it's important that your code is efficient so that way you can update more quickly. If I were to take this serial print out, because I don't really need it for the function, this is going to decay much quicker. So again, I still have this serial print and tell me what my pot position is. But you see that? It decayed so fast you basically couldn't see it. And that shows you that depending on how you set these things up, there can be a significant difference in how long it takes. Just to make that a little bit longer so you can see that it is still working the way it's supposed to. Let's add a little bit of a delay onto this. Hopefully that's long enough you can still see the decay. Oh, not uploading yet. See? Oh, you guys can't see it because it's being blocked by that. There's different delay functions you can use. There's a microsecond delay. So if you wanted to have a shorter delay than something inside here, you can use those as well. So I hope you guys have enjoyed this. The next thing I want you guys to do before our break is to focus on creating some combination here that produces a behavior by changing the code that you think is interesting. So some combination of flashing, button input, knob inputs, delays, however you want to do it. You don't have to restrict yourself to one button and one potentiometer. You can use multiple buttons and multiple potentiometers if you want to. You can also use multiple LEDs. Try and get a little creative and explore the different combinations you can do just using these simple elements. And have fun with it.